All right, guys, welcome to part 2 of Module 1, Lesson 8. So we were just getting started on this problem number 2. So it says, draw an array that shows 5 rows and 3 columns. So here it is, right here. So write an equation to match your array where the first factor, so that'd be this one right here, represents the number of rows. And then it says, don't solve it yet. So that's what we have right here. We have an array showing 5 rows. Whoops. Five rows and 3 columns. Okay, so we have 5 rows, 3 columns, but we're not solving it yet. Okay, so if I were to change the problem slightly, so here's the one we just did. Now, if we turned it on its side, but the first factor still represents the number of rows. So look at the differences between these two arrays. So what is the difference? When we rotated the array, the first factor would tell us the number of rows. So what did that do to the order of the factors? Okay, we changed the order of the factors. So the 5 changed to the 3 when we turned it on its side. Okay, because we couldn't still look at this array here and say that it was 5 rows of 3 because that wasn't true anymore. Okay, when we look at this array, we see we have 3 rows and 5 columns. So it wasn't 5 times 3 anymore. It became 3 times 5. Okay, so the total didn't change. So if we were to solve each of these by skip counting, okay, for this one we could skip count by 3s. So we'd have 3, 6, 9, 12, 15. So 5 times 3 is 15. Now if we came over here, we could skip count by 5s. 5, 10, 15. So did my total change? Nope, but the order of the factors did. Okay, so now we're going to do a few problems together on our problem set. So number 1 says draw an array that shows 5 rows of 3. This sounds a little familiar. So 5 rows of 3. You guys should be pros at drawing those arrays by now. Whoops, that's 6 rows. Oh, no, it's not. That was 5. So 5 rows of 3. Number 2, draw an array that shows 3 rows of 5. Okay. So over here we had 1, 2, 3, 4, 5 rows with 3 in each. And over here we had 1, 2, 3 rows with 5 in each. So 5 rows of 3, 3 rows of 5. Okay, number 3 says write multiplication expressions for the arrays in problem 1 and 2. Let the first factor in each expression, so that's here and here, represent the number of rows. Use the commutative property to make sure the equation below is true. All right, so for problem number 1, we're looking at the number of rows to be the first factor. Well, if we look at problem number 1, we know that there were 5 rows. So we would take 5 times 3. For this array, we know that there are 3 rows. So it would be 3 times 5. Notice where this problem came from? It should look pretty familiar. Okay, let's move on to number 4. We have quite a bit of work to do on number 4. It says write a multiplication sentence for each expression. You might skip count to find the totals. The first one is done for you. So part A says 2 3s. So 2 times 3 is 6. For B, it says 3 2s. So all we need to do there, so 3 2s is the same as saying 3 times 2. Okay, is that similar to part A? Yes, it is. They just switched the what? Factors. So if I know 2 times 3 equals 6, then 3 times 2 has to equal 6. Okay, next one, 3 fours. That's the same as 3 times 4. Okay, I don't know that off the top of my head, so I'm going to do a skip count by 3s just right here below the problem. So 3, 6, 9, 12. I skip count by 3s 4 times and got 12. Okay, let's look at D, 4 3s. Well, that's the same as saying 4 times 3. Do I need to do another skip count? Nope, because if 3 times 4 equals 12, then 4 times 3 also has to equal 12. Okay, next one, 3 7s. Okay, so that's the same as saying 3 times 7. Okay, I don't know that off the top of my head, but I can keep counting by 3s. So 15, 18, 21. So if I skip count by 3s 7 times, I would get 21. Okay, my next problem, 7 3s. That's the same as saying 7 times 3. I don't need to do a skip count because I've already done it for the last problem. So if 3 times 7 is 21, then 7 times 3 also has to equal 21. Okay, we're going to skip G, H, and I, and we're going to go on to number 5. It says, find the unknowns that make the equations true. Then draw a line to match related facts. So we have 3 plus 3 plus 3 plus 3 plus 3. Okay, and that would be the same as skip counting by 3s 5 times. So 3, 6, 9, 12, 15. Okay, B says 3 times 9. Okay, do I need to write out a whole new skip count for that? No, because if we look up here, I've already skip counted by 3 7 times, so I just need to do it 2 more times. So I have 24, 27. I just keep adding on to my skip count. So if I skip count by 3s 9 times, I get 27. Okay, let's look at C. It says 7 3s plus 1 3. This one's kind of tricky. So 7 3s is the same as saying 7 times 3. Well, I solved that one up here and I got 21. So 21 plus then 1 3. If I skip counted by 3s once, what number would I end up at? 3. So this problem is asking me to solve 21 plus 3, which I know is 24. Okay, now all I have to do now is match these 3 with their correct answers over here. Well, I know for D that 3 times 8, or 3/8, equals 24, which is what we just did down here. So 8 3s. So C and D would match. Okay, I also know that for part A, we skip counted by 3s 5 times to get 15, which would be the same as 5 3s. So E and A match with 15. So then that leaves B and F. So 27 equals 9 times 3. Okay, great job, friends. So you are going to do very similar problems on your practice page. So for your practice page, you are going to do number 1, 2, 3, 4, and 5. And you'll notice that those look very similar to the problems we did on our problem set. So good luck. You guys will do great. Just try your best. Okay, I'd rather you try and get the problem wrong than not try at all. You guys can do it.